So thanks for coming, everybody. We've almost made it to the end of a long week. Only 3 more talks to go. So you're in the home stretch. I'm Jeff Kelley. This is taking control of errors in Swift. I work at a company called Detroit Labs in Detroit. We're kind of a consultancy, so most of my time is spent building apps for clients. So I have built a lot of apps that handle lots of different kinds of errors. The thing about error handling is that every app handles errors. Some apps you're lucky enough to know how. Because things are going to happen, and then your app will handle it somehow. So the thing is, good night, everyone. So this is one way you might handle an error, right? Is you might just throw your hands up and say, I can't handle whatever's happening. Tell the user, sorry, you're out of luck. This probably isn't the best way to handle most errors, like if a network call fails, but there's some hardware situations where this is actually the best course of action. You don't want to keep going because you might mess something up. So we're not going to talk about a whole lot of different actually handling errors because it's going to depend a lot on what you're doing. We're going to talk more about how the whole process works in Swift. Before we can talk about how it works in Swift, though, we're going to go back in time a little bit to talk about how it worked in Objective-C, because to really understand why Swift works the way it does, you have to know where it came from. We'll talk about how to test things in Swift, and then finally we'll talk about how some of the new stuff we have this year is going to make this a lot easier. One caveat there is that I've been traveling a lot, so I have not looked at all the code with combined and SwiftUI here with the newest betas, so it may not work. They've been changing a lot. Your mileage may vary. But let's get started. Let's talk about the history of how this has all worked. Who here programmed in Objective-C before Swift? Oh, that's more than I expected. Wow. So this should be pretty familiar to most of you. If not, here's how it basically worked. You would create a pointer to an NS error, and then you'd call some method and store the result of it in a Boolean, here called success. So how do we handle this kind of error? And the straightforward way you might think to do it would be just to say, okay, well, after this finishes, is that error nil? And if it is, or if it's not nil, then handle it somehow. But the thing is, Objective-C is a very old language, and back when the iPhone first came out, that pointer storage for that error, that was a lot of space. And so, in the case where that method knew it wasn't going to fail, it might use that pointer storage for something else. And it wouldn't clean that up before it was done, because that would kind of defeat the whole purpose of that optimization. So really what you had to do was you had to first look at the value of success, and only if success was false, or no in Objective-C terms, then you could look at the error. Now we're going to come back to this pattern later to see how this gets imported into Swift. But this has been, the standard for a while. But you can't just use the value of the error there, because you have to know if it's a success. And that's that highlighted. So another common thing that happened as Objective-C went on is we started writing more and more asynchronous code, especially when we had devices that had multiple cores. Now this is a completion handler for starting a workout on an Apple Watch from your iPhone. Anybody who's ever written any watch kit knows that handling errors is a thing you're going to have to do a lot of. So here, our callback has 2 parameters. We have a success, and we have an error. And that error could be null. That's what that null means. And this pattern was so common that now we have a type for it in Swift. We call it result. So a result can either be success or it can be failure. It has some success type and some failure type that has to be an error. And we'll talk more about the error type later. That frozen at the beginning, that's Apple telling you that this enum is never going to change. You don't have to worry about some third case being added here. It's either a success or it's a failure. That's it. So this works really well for asynchronous code. We can have some perform request method. It goes to the network, it gets some data, and then it comes back with this result. And here, if it's a success, we have some data we can parse into a model object, and if it's a failure, then we have some error that we can handle. And we'll take this a step further. A lot of the time, we'll use map. So here, we have map takes a transform that turns this success type into a new success type. And we can chain that in here with that existing result. So if we have a result, we will parse that data, and if there was an error, it will just pass straight through. Now, that gets you pretty far in Swift area. The problem is, I was going to highlight that. So the problem is, you can't force people to handle errors. It's something we know that we should do. It's kind of tedious. And then when somebody asks if we're doing it, we get a little embarrassed, kind of like flossing. Quick show of hands. Raise your hand if you brought floss on this trip and haven't used it yet. Some people there, yep. I actually did floss right before this because I was thinking about it with the slide, and I finished the floss in my travel container. So it is possible. They do end. But the thing is, like, we know that we should handle errors better, but we don't always do it. Here's what actually happens. We have a to-do. And that to-do, it can live for a long time in a code base. It could live the entire life of the code base. Now, depending on the kind of team you're working with, this can go a few ways. If you're a one-person team, this might never actually get tested. At Labs, we're very lucky that we have very good QA engineers that will catch this kind of thing. But a lot of people don't have a lot of resources and really are only testing the happy path. You might not ever see this error case even. Right? You can just write it like this. And now there's no to do, there's nothing that you can suggest an error might happen. So what's your app going to do if that network request fails? Well, I don't know. It's just not going to do anything. I don't know what kind of state it's going to be in, what the user is going to see. And this isn't new. It would happen in Objective-C, right? We've got a to-do, and at least here we're logging it. That's something. It's not nothing. But of course, there's nothing stopping you from not having that else in there. And even worse, you didn't have to make that error parameter. So instead of having an error, I'm just passing null. I use null here because it's a pointer to a pointer, and it's a whole Objective-C thing. If you want to argue that, just find me tonight. The thing is, also, if you're writing one of these methods that takes this error, you have to account for this case and not crash if somebody passes null. That's super fun if you're like writing a framework or a library or something. Okay, so that's our baseline, right? We have a couple ways to handle errors, but there's no real good way to make somebody do it. So when Apple went out to design Swift, that was a problem they wanted to solve. So how did they do that? Well, let's look at this method from before. We have an NS file manager that has a remove item at path error method. Now in Swift, that's just called remove item at path, and there's no error parameter. But it has this thing called throws on it. I'm sure a lot of people here have used things with throws. If you want to call this, make a file manager, call remove item at path, this won't compile because it's not marked with try. Any method that has throws marked on it, you have to call try before you attempt it, and put that in a do block, and then the error will happen in the catch. That error is still there. It's implicit inside that catch block. Now these errors aren't like exceptions in Objective-C or C++ or other languages. They're just types. But what are they? Well, if you command click on error in Xcode, this is what you'll see. It's an empty protocol. But that's kind of handy, because you can make your own very easily. There's not a whole lot of boilerplate to implement. If you know specific error cases you're likely to run into, you can just throw those in an enum. So here we have some errors for parsing our data into a model object. Now we can use this with our catch. If I try to parse some data, and then I catch the error that it's invalid data, inside that catch, I know exactly what the error is and can handle it. I do still have to have another catch with nothing on it because I don't know what type will be thrown. So we do have to handle all errors. But of course, even though they tried to handle the problem, it didn't actually work because you can always just use a question mark, or even worse, force unwrap it here. And this puts us back in square one. We have this code which could fail, and we don't handle that. We don't know what's going to happen. Well, we know what's going to happen in the second case, is if that fails, your app is just going to crash. Probably not what you want. In the first case, it's just going to fail silently. And that's probably not great either. So, if we want to encourage people to handle more error cases, we have to make it easy. And if we don't make it easy, people are just going to fall back to not doing it. Now, it is useful to be able to write this in our own code. I can put throws at the end of this method, and then anyone who wants to call it delete secret identity has to call it with try. And in fact, I could have multiple change methods. So this thing throws, we're not doing any do catch here. We're just going to try, and then because this method throws, if that thing fails, it'll pass it back to whatever called this method originally. So we can just keep going and nothing happens. Of course, we use map all the time, and this has a different construct in it. It has a rethrows keyword. Now you've probably used map a whole bunch without having throws or a try in there, and that's because rethrows only takes effect if the closure you pass in itself throws. So if you throw in your map closure, the map itself will rethrow that error to the caller. So that's how you've been able to use map without try in the past. And you can do this yourself. You can write your own method that rethrows. This is a pretty simple implementation of map. We're just going to try the transform on each item, and it'll automatically throw up to whoever called it. So that's pretty neat. It's some handy code we can write. Other things you can do with error, they have a localized description. And we can use that maybe to log it out in some kind of logging framework that we have. And in fact, you might find yourself writing code like this a lot, where here we're going to add some samples to a workout in health kit, which could succeed, it could fail. I'm not exactly sure what you're supposed to do if adding samples to a workout failed. There's not a whole lot health kit tells you. But at the very least, we're going to want to log that out. So when we're writing the app, we see it in Xcode. Well, maybe we see it in Xcode. It's kind of iffy if log messages show up. But I found myself doing this thing a lot where we have a message that said there was an error doing something, and then we would pass the localized description of the error. And it basically looks like this. If there's an error, log it out with some context. Now, I like to flip this a little bit and make this an extension on error. So we can log it with some context. I like to give it a file name and a line number. So this is useful for any kind of logging or testing framework to show the actual original file and line number where this happened. So here we're just going to log this error that it happened with a localized description and some context that we pass in. And now when we want to call it, it's a lot cleaner, because I don't even have to unwrap the optional. Just if there's an error, log it with this context, which is better than nothing. So that's the Swift error type. It's useful. You can make your own. You can put extra info into it. Because it's an enum, you can have associated values. We see that a lot, like with Codable. But that still doesn't solve that problem. Right? We're still not super incentivized to handle it. But one thing that we might want to do is test our app. And testing the app is pretty easy because result, if the success and error types are both equatable, then the result is equatable, which means an XC test, you can call XCT assert equal, and you can just make sure, hey, make sure this is a success. That's great. So now we know that when this test runs, and hopefully if you're testing network calls, you're not actually hitting the network, you're using something like HTTP stubs or some other framework to mock data in there. But here we just want to make sure that the request finishes and we have a success. And it's just as easy to test failure. So here I have spelled Shazam wrong. So because in this universe the Sinbad movie never got made, this Shazam spelling is wrong. The DC hero is spelled, I think, with either one A or two Z's. I can't remember. But here it's just as easy. We just call XCT assert equal, and we make sure that it's a failure. And we can say that it's a specific failure. Here we could say, because I spelled that wrong, it should be a not found error. So that's nice. But the more tests you write, the more you wrap up all the possible code paths in your app, there's one thing you can't shake. And that's fatal error. Fatal error is a useful escape hatch for when you don't know what to do when an error happens. You can give it a string, and that's nice because you can pass the error's localized description there, and Xcode will tell you in a little red overlay what the error was. But sometimes you'll want to use code coverage. And every now and then I'll have a client who has this big IT organization, and that IT organization sets these standards. And so we have to abide by certain code coverage rules. And in fact, if you submit a PR, and that PR makes the code coverage go down below some arbitrary threshold, it will get rejected. Now, code coverage itself is not the be-all, end-all tool for testing your app. All it tells you is which lines executed when the tests ran, just which lines of code were run. But we can't test that with fatal error, because if it ran that line, it would have crashed. It's a fatal error. That's what fatal error does. So we're stuck. And more than anything, aside from wanting to hit some arbitrary number, I just want to know, I want to make sure that my app works the way I think it does. So I want that red box to be gone. Now, for throws, it's pretty easy to test, right? So here's a dumb method called throw if passed false. If you call it and you pass false, it will throw a throw-in error called passed false. Now this is super easy to test, right? We just call XCT assert throws error. We can try calling it with false, give it some message that we expect it to throw, and then it'll give us the error, and then we can just make sure that that's the right one. So that's pretty straightforward for throws, and that's kind of the API I would want for fatal error. So I found a bunch of blog posts. I've been scouring the internet for ways to do this. And the thing is that you can make your own fatal error. And if you put it in your app's code, the way that Swift works, it's going to call your version of fatal error before it calls the Swift's version. So we can make sure that our parameters match what fatal error has, and then it returns never because it's never going to return. And by default, we can just call into Swift's fatal error. So this won't do anything, right? It's just going to call straight through to Swift's. Might even get optimized out. So that's not too useful yet, right? But one thing we can do is we can make this fatal error utilities struct here, and our method, instead of just calling it a Swift's, it's going to call into some closure that we've stored. And by default, that closure is just going to call Swift's version. So, okay, still not too useful. But one step further, we can replace that fatal error closure with one of our own. And now, when you call fatal error, it's just going to call that closure. And then we'll have something to restore it so that we don't leave that in there at the end of our test. Now, you'd only ever call this from a test. You don't really want to do this in production. Maybe you want to log something first, but chances are, if your app is going to have a fatal error and crash, you're not going to want to do too much at that time. So now, in my XC test case, I can write this method expect fatal error. And what this is going to do is it's going to take this test case closure, it's going to put that on a background queue, and it's going to call it, and then it's going to have replaced fatal error with something that fulfills a test expectation, and then it's just going to call unreachable, which runs the run loop forever, because we don't want to get past that method. We can never return, because it's a never return type. And that's why we put it on a background queue, because it's never going to finish. So when this runs, and then our code calls fatal error, it's going to hit that callback, it's going to fulfill our expectation, the test is going to pass, and it's going to look like that when we call it. So that looks super nice when we're actually calling that in our test. It's very straightforward what we expect to happen. And now we get a green thing in our code coverage. So it's one line of code coverage that may or may not make up to whatever arbitrary limit you're looking for. But more importantly, this lets you reason about your app's behavior. Now I know if a certain thing happens in my app, this fatal error is going to be called. Because even worse than crashing your app is your app not crashing when it should. Because who knows what's going to happen then. So when do you use this? The previous version of this talk, I suggested that maybe if you had a table view that was looking for a cell and couldn't find a cell of the right type, just make a blank cell and return that blank cell. And 100% of the feedback I got was about how you shouldn't do that. It was an arbitrary example, but whatever. So let's say you have a table view, and you're going to dequeue a cell. And you want that to be the myTableViewCell class, but something happened. Maybe you mistyped something in the storyboard. Maybe you didn't realize where your keyboard had focus, and then you changed an identifier in the storyboard, and you didn't notice, and then you committed it. Not that any of us would ever do that. But so here, if we don't have the right thing, we can use fatal error, because we don't know how to continue if we don't have the right kind of cell for our table view. So maybe that's what you want to do, maybe it's not. But the thing about fatal error is it's all or nothing, it's going to crash. But there are a bunch of assertion methods. Well, there's three. There's fatal error, there's precondition, and there's assert. And fatal error, no matter what, will crash. Precondition, you pass it with some condition, and if that condition is false, for debug and release builds, it's going to crash. But if you're using the -O unchecked optimization level, it's not going to, because you're saying to the compiler, don't check anything, it's going to be fine. Assert will only go in debug builds. So this is super useful for developer level things, things that you only want to see. And then when you actually ship your app to the App Store, they're not going to crash the app. Now these are identical. For assert and precondition, there's assertion failure and precondition failure, where assertion failure doesn't take anything, it just always fails on debug, and precondition failure always fails. So let's clean that up a little bit. Let's clean up that example with our table view cell. So I like to call these programmer errors, things where I'm telling myself, hey, you messed up somehow. And in this case, no cell being returned, that to me means I've messed up my app somehow. So I have this method here on UI table view that will dequeue based on some generic table view type with some reuse identifier. And all it's going to do is ask the table view to dequeue and then double check that it's the right type. And if it's not, it's going to throw that error. And if it is, it'll just return it. Cool. So now when we use it, once again, we have our do catch block with our try. We try to dequeue our cell, and if it works, that's great. If not, we'll take that error and pass it to fatal error. But now there's still one thing I want to change in there. Because now I'm just passing that localized description to fatal error, and that's a lot of boilerplate to pass around all the time. So I'm going to write another wrapper here. And this one is just going to take an error. So now I will just pass the error into fatal error. it'll take the localized description out and automatically show that message. Great. So now, we'll get our table view cell, and if it's the wrong type, we'll just throw that fatal error up. So you can also put this in your tests, right? Once you have a version of fatal error that takes an error object, now we can write tests to make sure that the exact right thing is being passed to fatal error. Because, again, you want your app to crash under certain bad conditions, but you want to make sure they're the right ones. So we want to expect a programmer error, but not some other network error thing, right? So this method here, it takes a specific type of error for expect fatal error and builds an expectation like before, but then at the end here, it's going to call xct assert equal on those two errors. So now we make sure the thing that we got passed into fatal error is the right thing, and then we can totally reason about the behavior of our app, even through things that would cause it to crash. Okay, so we've made it a nice test. We've made it easy to get code coverage, but there's still nothing kind of forcing us to handle these errors. We can always still just leave them on the floor. And this year with Combine and SwiftUI, Apple has given us some additional carrots and sticks to solve these things. So Combine, if we haven't looked at it yet, it's kind of like RX Swift or any other reactive framework where it's values that change over time. In Combine, there's a thing called a publisher. And a publisher has two associated types. There is an output and there's a failure. So that looks pretty similar. It's kind of a lot like result, right? And let's look at one. Let's look at a concrete example of a publisher. This is, there's the output type, and there's the failure type. Now, failure has to be an error. Okay. So if we look at the data task publisher on URL session, this is one you're probably going to be using a lot. This will just call with your output, and the output has data and a response. So Swift is nice. I don't know if you were in Janie's talk before this one, but we can have tuples that returns. We can show multiple values. Now the error here is going to be a URL error. So they've defined the scope of errors that might occur. So that's pretty great. Let's use it. So just like before, we have some URL that we want to hit, and then we use URL session. But this time, we're going to use a data task publisher, and then in this other publisher, what we're going to do here is it's called a try map, kind of like map before, only this time, if there's an error, it's going to have an error type. So we try to decode our model object from the data just like before, and return it. Now this erase to any publisher, don't worry too much about that. It's just type erasure so that your types aren't super, super long. Now some publishers don't need a failure type. Notification center, for instance. You can get a publisher for a specific notification that will just call you whenever that notification fires, but I don't really know what that would mean to fail. Notification doesn't happen. Like there's not really a good way for that to fail, right? So let's look at what Notification Center is using, because we know it has to have some failure type. That's part of the protocol. And it turns out that the failure type for Notification Center's publisher is never. So they're telling you this can never fail. And here, that's appropriate. Okay, so what does that have to do with SwiftUI? So, and this is where I'm not sure if this syntax is up to date because they've been making lots of changes in the betas. But in any case, you have this bindable object. And the bindable object is a way to drive SwiftUI's UI off of your model object, right? So it has to have a publisher type. And that publisher type's failure has to be never. So what that means is Oh, and here's how you would use it. So we have some object binding for a model object that we had before, and then in our SwiftUI view here, we're going to use some properties. And SwiftUI is really intelligent. Once you actually get values out, then it's going to know to update when those change. So if we wanted to put those things together, if we wanted to get a URL sessions publisher and put it into our SwiftUI, we have to do something, right? Because the failure type wasn't never. There's a couple things you can do. One thing I like to do is have a placeholder value. So for a placeholder value, this is something that represents a basic object that's not loaded yet. So here we just have an unknown for the name. And so for our publisher that takes the data and turns it into a model object, we're going to use this catch operator. And catch, what it's going to do is going to replace, it doesn't replace the value of the publisher, but it replaces the publisher itself when it encounters an error. So if we have an error here in our publisher, we're going to replace it with one called just. And just is a publisher that just sends a value. And in this case, it's just going to send our placeholder object. So now that we've done this, we're never going to have a failure, because if that network request fails, we'll have some placeholder object. If you've used RxSwift, there's a similar concept called a driver. Driver kind of encapsulates putting things on the main thread and then getting them into a state with no errors. It's used a lot for like table views. So you would drive a table view in RxSwift. And it's the same kind of thing where you would say, when you make the driver on error, just return this. So it's pretty useful. So, and there's a whole bunch of other things. There's a really good WWDC talk that you can look at that shows some examples of how you might handle errors in Combine. You can retry, you can do all kinds of neat things. But the important thing is, in order to use it with SwiftUI, you have to handle it. So finally, after all this time, Apple has finally given us a way that forces people to have to handle these errors that come up. So that is a tour of error handling in Swift. We went from Objective-C all the way to Combine in SwiftUI. Looks like I went a little bit fast, so I'm a little bit early, so we have plenty of time if anybody has any questions. No? Okay, well, I'll be around. So if you have any questions, come up, but otherwise, thanks for coming.